In today's lecture, I would like to talk about the phenomenon of one-piece flow. It can happen in a repeating assembly line or a high-mix manufacturing cell, although the latter case may be a little more limited. But the whole idea of single-piece flow comes from assembly line balancing, and implicit to one-piece flow is the assumptions that pretty much every product that is going through the line is having the same amount of processing at each station in the line, and the transfer time from one station to the next is zero. Once that feature is eliminated, we have the phenomenon of batching. And batching is what leads to, in one form or the other, the seven forms of waste: overproduction, inventory, transportation, overprocessing, waiting. There are seven forms of waste. And batching occurs for a variety of reasons. It's one of them is just the mindset. The person at station one decides to produce the entire batch of product and only then transition it to the next workstation. Sometimes it is the process that forces that. For example, heat treatment. You cannot heat treat one piece and then the next piece in a batch. Often it is the situation with setup times. When setup times are high and the production planning method is material requirements planning, there's an automatic direction to the production floor to produce big batches so as to minimize the total time lost in making multiple setups. But in most cases, and the justification for creating work cells is that the layout often is the culprit. So as soon as the transfer distance from one station to the next becomes large because the distance of separation between those two stations is high, there's a natural tendency to batch, because only when the batch is created, then one operator will come and decide to leave their equipment idle and push that batch to the next station. And finally, in many cases, batching is created just by the nature of the containers which are used on the floor. So there's a big container that delivers the raw materials. There's a big container that the customer expects in which to receive their product. And if those containers are maintained even on the floor, pallets, gaylords, wire mesh containers, automatically you have the phenomenon of batch production. And when you have batch production, it takes a long time to complete an order. Working process is very high on the floor, and a lot of floor space is needed to hold the big batches of parts. So there's a mathematical formula, it's called Little's Law. And the Little's Law essentially connects the working process in the system, the average time that a particular piece in a batch stays inside the system, and then how much time it takes for the system to process a particular piece. So when you look at Little's Law, right there is the mathematics which will help to justify that single piece flow is the preferred waste-free production mode. And when you violate single piece flow in one form or the other, you will automatically have an impact on order completion time, work in process inventory. So this first video which we will see is a simple animation of one piece flow versus batch. And after that, I will record one after the other a series of videos that I've specially selected because those videos either demonstrate good one piece flow capability or violation of one piece flow capability.
If you're a small or medium-sized manufacturer, you have big plans and big ambitions. ECI manufacturing.
So the lowest line is single piece flow. The original batch size is 10, and the intermediate transfer batch is 5, meaning that the original order size was broken up into two transfer batches of 5 units each. This line is definitely an unlean line, and I will let you decide as you see the product flow, the people flow, and the machine utilization. You decide if it's unlean or lean. So when you are watching this video, when you want to recognize the forms of waste, look for the behavior or the activities of three entities: the product itself, the machine, especially the bottleneck machine in the line, and the operator. Look for those three entities, and if you don't see them engaging in value-adding activity or being processed, depending on person or product, that is itself a violation of lean behavior. This next video is perhaps the biggest violation of one-piece flow. Whoever posted it on YouTube claimed that it was single-piece flow, but frankly, uh, the number of violations of single-piece flow are humongous. And in fact, I've always challenged my students. Either I discuss them in class or I give a homework to the students with this video, and I say, follow this video from start to finish, and I would like you to take at least 20 screenshots that capture, in one form or the other, unlean practice. So if there are things like safety, for example, here you will notice that they don't have safety glasses, and many times the welding flash uh, occurs while somebody does not have their ultraviolet protection on their face. Every time they say one piece flow, it's just the product being moved, but it normally gets dropped into a container. Gets put on a table. One piece flow is where as soon as the piece gets processed and completed at one workstation, it automatically goes to the next workstation and processing begins. Anything otherwise is basically waste. There is delay and there is transportation. So this is again another example of what I would call a poorly designed work cell, which does not have one piece flow. You see safety glasses, you see those big containers with pipe, you see the second saw is not being operated. You see this container that's acting as a tabletop or collecting. You see him walking. See now he goes from this saw to this saw. Like I said, you should be easily able to find at least 20 violations of continuous flow. And of course, safety, cleanliness, dust evacuation, welding fumes evacuation. 20, at least 20 violations. Unleanness, as I would call it. So I would like you to watch this here. This person is doing the tack welding, but this welder is essentially the supplier to these two welders who do the finish seam welding. So as you watch the video run, start asking yourself how productive are those two welders with regard to this person. And then you'll probably think of theory of constraints. Theory of constraints as exploit the bottleneck. So think about connecting bottleneck management and this whole thing of weighting waste. Now watch. This welder has created a whole batch of finished product. His pallet is located here. So since the distance does not allow one piece flow, see what he does. So we talk of one piece flow. Well, you just saw, right? This gentleman who did the tack welding, he's continuing on his own merry way. So he'll basically create a batch for this gentleman while he puts all these finished product on the pallet and then goes back onto that station. But the question is that if this pallet could have been rolled under the table or just such that as soon as they finished the piece, he could have probably put the part on the pallet, then this kind of waiting would not have occurred. Would you like to be bending down every day like this? Maybe to put one or two pieces each time. Imagine how many pieces are in this pallet. There's about 30, maybe more. And for every two, he bends down. Uh, Not exactly a great job. So again, with lean, safety and ergonomics are probably the most important. Then comes quality, then comes delivery, then comes productivity and cost reduction. So SQDP, as some people might say so. Now, I know that this person is pretty much doing the same work as this person, but his palette, everything is behind the screen. I'm guessing. You can see that there's going to be some amount of waste and delay as he goes looking for a pallet jack or something to bring it around the screen and then pick up that pallet and then roll it out and bring it out here for the forklift to take it from there. So that's again pointing to the poor design of this work cell. See, why do people have to walk? Why do people have to walk? And given that this is a cylindrical product, it could easily roll. So that begs the question, why aren't some short roller conveyor segments created or little inclines put so that, you know, like could this table have been inclined? Could it have been joined to this station? Why does the person have to walk? And because that is basically operator motion waste, there's a travel delay, it creates some form of batching, and there's a processing cost. So anytime you have to move a product using a person or a separate piece of equipment, aha, that should be easily sending off bells and whistles in your head. Oh, I see waste, I see delay. Now you will see good examples of one-piece flow cells, and now I would like you to recognize that these next few videos are pretty much close to being perfect as far as one-piece flow. But again, if you look at the variety of product that they produce, there's only one product being produced at a very high volume. However, even that concept gets turned upside down when you see what is called a D cell or a single person high mix assembly cell. So this next one is real one piece flow. It's a good lean cell, and I will maintain silence. Work instructions in front of the employee. Everything is point of use. Error proofing signals were indicated. Very clean workplace. Fixtures act as transportation devices. Empty containers are sent back to the front of the line. Pretty amazing. Again, caveat is how many different products do you see being made? So the big question here is that it is lean, yes. Very lean, high volume, repetitive, balanced assembly cell or assembly line, granted. But what would have to be done if this particular line had to adapt for a high mix of product? And that is where, lean done the Toyota way is not flexible, it's not agile. And the future, where we are going to be, each customer gets product made to suit him or her. The future is going to be about flexibility and agility, reconfigurability and resilience, the ability to withstand shocks, like when the COVID-19 pandemic occurred. Again, my concern is no safety glasses here. They're wearing, beach slippers. I don't know. Would you like to be standing at the same spot for 8 hours, doing the same thing over and over again? That is why sometimes the cross-training of employees and what is called a moving line, where a person moves with the unit of product that they are building completely from start to finish and then walks back to the front of the line. Then they end up being cross-trained and have the variety of making a product unit completely on their own. Of course, then there are issues of quality and variability. So there's a downside to being cross-trained and making one employee capable of producing the entire product. But you will see that as the level of automation and machine intelligence and process intelligence increases, that day is not far away when we will have what I would call high mix, low volume cells, where the volume would be a lot size of one. This next, the lean assembly line at Atlas Copco, that's again something which you should see. And it's in the syllabus. In fact, let's go to this one. I mean, this is pretty impressive, but once again, this is a single product, highly repetitive. But just watch, it's called a Chaku Chaku cell, load, where the operator loads the part, starts the machine, walks away, goes to the next machine. She doesn't stand at any particular machine. It's a continuous flow in a clockwise routine. It's one person, one product. She handles the assembly from start to finish. Pretty amazing. Just a Chaku Chaku label. If you'll notice this machine here with the conveyor, that's the buffering point. That's the one workstation where multiple products can be seen on the machine. Everywhere else, it's a single product. So that may be because the cycle time is much higher at that particular station. But you can see as this work flows, this is exactly crying out for today what is called cobot assembly, collaborative robot. And now the employee does a lot less, and the robot, in some cases, is programmed with appropriate fixtures to assemble the entire product. What's amazing here is that she is inspecting the product herself. There's none of this, oh, let me make a batch of parts And because management does not trust me, the operator, to check the quality of my own work, let me send that batch to a separate inspection department. And when they check the batch and get back to me, then I will continue producing the rest of the demand lot size. Inspection is built into the product, and the operator is trained and held responsible for the quality of their work. Duh, but most of the machine shops, the clients I work with, I don't see that. Inspection is in its own functional department. Now, this next U-shaped cell example is features Paul Akers. He is an entrepreneur and he runs a company called FastCap. And if you go on YouTube, tons and tons of videos featuring lean being implemented at his company are featured. Um, what I think is fascinating and I think admirable is that he's the CEO of the company. When the Japanese consultants came and implemented lean in his facility, he learned what they were doing. And then when they went away, he became the champion. So he's very hands on. He leads by knowing, he leads by doing, he leads by inspiring. And there's never a sense of bullying or intimidation in the way he deals with his employees. But now here's the downside. Whenever I've seen any of his work and whatever his books, 2 Second Lean, the impression I've gained is that it's overkill of some basic concepts like visual management and 5S and one piece flow. All very good, but many times when the employees see that the CEO only knows so much and only does so much, then they start doing only so much and learning so much. And that's the downside. So when the person at the top tries to lead a lean transformation, sometimes they could be the worst enemy of the transformation because the employees don't get a sense that they could do something very innovative. That's not something that he would have thought of. But maybe he does that, but I don't see that in any of his videos. But here, what is impressive is that he presents a single person U-shaped assembly station where the product gets started and finished in that one area.
Hi, Paul Akers here. I just got an email from Nathan who just finished reading 2 Second Lean and is starting to make lots of great improvements in a two-man cabinet shop. And he had a question. He said when he read the book, he noticed that when the Japanese came in here, Brad and John, they turned everything into U-shaped cells. And he wanted to know, when should we go to U-shaped cells? When is it more efficient? Well, I can't answer that question absolutely, but what I can tell you is a U-shaped cell is more efficient because you don't have to move as much. When you reach over to one area, it's just in a nice U-shaped area. Now, not everything in our facility is a U-shape, but this is our workbench, and this is a modified small U-shape. You can see that when I want to get the screwdrivers, they're right down here very easily, or when I want to get the pliers, they're right down over here. And as you can see, I've got a nice workbench in front of me, but I've got that kind of modified U-shaped cell. Now I'm going to walk through our facility and show you all the different U-shaped cells that we've set up. But it doesn't have to be U-shaped. The idea behind U-shape is that from one position, you can turn to the left and you can turn to the right with minimal amount of movement. If I did a long table, I would have to walk back and forth all the time. With the U-shape, it allows you to turn, access the products very easily, and that's why the U-shape is so powerful. So let's take a look at some other ones. This is my favorite U-shaped cell. This is actually cruising cap. We make a coffee cap lid, And you can see this is a very deep U-shaped cell. You can walk into this, and we can have one person in here, or we can have 10 people in here. And you can see everything's made very easily. This is just a particle board countertop, and this is OSB that we painted. And then we have our bin system. We actually developed this bin system here at FastCap. It's a cardboard POP, if you will, that has little partitions in here that we can section off depending upon how much of a particular product we inventory in the Kanban. So for instance, this product, we use a lot more of it, so we have no partition, and we fill this entire box. Where another particular cruising cap that we got made, we actually have 3 partitions, so we maximize the space. And the nice thing about this is, this thing can go right over to the production area where they make the cruising cap, and I'll show you what that looks like. So if I come over here, this is a bin system for our min-max, and then this bin needs to be made, and it's turned on side. So the same POP, we get to use it for both inventorying product, and then when it's empty, it needs to be rerun. We put it back in here, and through visual controls, people can easily see that this needs to be run. Well, if you look at these other ones, they're full, so this inventory level has been met. So the bin system allows for very easy management of inventory, and this U-shaped cell does a great job as well. Now, it just so happens that the actual machine that we're making that on is right over here, so the operator can very easily see through visual controls what exactly he needs to run at any given time. And of course, if I'm over here packaging, I can look over to Yuri real quick in a split second and say, Yuri, hey, can you run me some more cruising caps? And he can say, no problem, what do you need? Very strong connectivity between manufacturing and packaging, and that saves a lot of time. And you can see we have lots of U-shaped cells all the way down here. And these are all the packaging areas that we actually package the FastCaps in. And you can see we've got nice cells set up, and we have overrun, if you will, or excess inventory. Not a whole lot of it down below, but our main packaging area is right up here. You can see everything's color-coded. We poke-yoke everything. So if someone's packing right here, and they want to know what this material is, it's unfinished mahogany, but if I looked at that, I wouldn't know. But of course, we've got the actual product taped to the back and then labeled with the size and the material type. And that saves a lot of mistakes from happening. So it's very visual, very easy to work in here. And again, I could have a small order for the day, and I could have one person in here, or we could have big orders. We could have 5 people working in this cell. So it's very flexible, and that's another reason why we like the U-shaped cell system. And this is what the Japanese set up when they first came in here. But at the same time, we have regular straight cells right over here on this side when we're producing. Now this is just a small single cell that's actually inside a racking system, as you can see, and we can manufacture all the parts. And again, we try to keep everything very simple. We have our boxes tilted up on angle. This is that same bin system. This actually one that's made out of wood, but similar to the cardboard one. We mostly use the cardboard one. And you can see all the parts are put in the order that you would use them, and then they just go right on through. And we have a mold here for holding something down. We have the battery charger installed in place. It just allows for easy, quick manufacturing. And of course, the inventory is kept down below in that same bin system, which is right here, easily labeled with all visual controls. The part is actually glued right on the front with a label. That's a big thing we do here at FastCap, is we like to do visual controls, so we actually put the part and a label, which makes it easy for people to understand what we want them to do. So hopefully that helps on U-shaped cells. We do them everywhere throughout FastCap, but we do modified ones as well. It's not important that you do it exactly like us, but understand the power of a U-shaped cell is to eliminate motion, transportation, and excess waste. Thanks a lot.
Now what I would like to feature are 2 short videos which I think either represent what's already going on in other countries and surely in America also, just that I do not know. These are, one of them is the case where one person is assembling any variety of a particular product, and the entire cell is automated. All assembly steps are automated, inspection is automated, instructions are computerized. Even the delivery of particular parts are controlled in an automated system. Very impressive. And so this is what I call a single person high mix assembly sim.
Johnson with Elvers and Baking, and I'm headed to the bake right now to the passive income check. I love
Workers in this Japanese factory have said goodbye to the assembly line and hello to the D shop. Roland DG is manufacturing everything from industrial printers to milling machines to vinyl cutters, using a single worker to assemble a product with thousands of parts from start to finish. These one-person work stalls, however, have a lot of digital help. A range of high-tech gadgets from 3D graphic monitors to digital screwdrivers help workers make every one of the company's 50 products.
約2日間にわたって組み立てに必要な基本的なスキルを身につける研修を専用に設けられたトレーニングルームで受けてもらいます。研修後は比較的短時間で組み立てすることができる小型のプリンターや小アッセンブリ、つまりユニットの組み立てから始めてもらいます。組み立てするにあたって、ネジ類の消耗品に関しては部品供給ラックから、取り出します。取り出すとパソコンの画面には、電気ドライバーでビス止めするように
The computer keeps track of every step, ensuring correct components are used and the correct number of turns are applied to a screw. Workers' speed and efficiency are monitored, and bonuses are awarded based on productivity.
そのパソコンで、記録された工程の履歴をもとに早い人の作業というところはどういった工夫がされているのか、簡潔なるのかというところを、現場を管理しているスタッフが中心になってこの膨大な生産ログを使って、しっかり分析して、分析した結果を教育であったり、実際パソコンの画面で表示される、作業指示、作業コンテンツの方に落とし込んで全員の底上げをして、ばらつきを抑制したいという活動を行っています。
While cell manufacturing, as it's called, isn't new, Roland DG says the use of digital gadgets speeds up production time, lowers defects, and helps it keep workers motivated in a market crowded with competitors. At the end of the day, the computer displays the time it took to complete the job and even gives workers a pat on the back,
お疲れ様でした。
which means you must be tired, and we thank you.
Then this is the last automated cell. This is a Bosch cell, and I believe Bosch is highly reputed for their implementation of lean. So it is not surprising that their adoption of Industry 4 is kind of driven by lean thinking. And so they're looking at Industry 4 essentially eliminating any and all sources of waste and imbalance and error. And I don't know, the video really does not show much about this particular line, but think about it. Every manual activity that you perform, every element of waste which is caused by manual effort is essentially attacked with Industry 4 capabilities.
Bosch Rexroth exploits the advantages of intelligent, autonomous Industry 4.0 solutions. On a multi-product line with the Bosch Rexroth plant in Hamburg, 200 different variants of a hydraulic valve product are assembled economically and with no retoolings. The assembly line connects people, machines, and products. The line consists of 9 autonomous, intelligent workstations. By means of an RFID chip, the product is controlled independently by the assembly line. The work steps required are displayed to employees on screens at every workstation. Modifications are not necessary. This increases productivity by approximately 10%. Kanban systems and supermarkets only provide the parts that are actually required. The result? A 30% reduction in stock. An app for fault and deviation management increases availability. All that is required for diagnostics is a smartphone or tablet PC. Each station recognizes employees by means of a Bluetooth tag and adjusts the work area to the individual's requirements automatically. Language, qualifications, and preferred font size. The interactive manufacturing system collects, filters, and visualizes production data continuously. The employees see the information in real time and can quickly come up with necessary solutions. This reduces downtime and increases productivity. Industry 4.0 is already possible today with products and solutions from Rexroad.
So that does it for this lecture. I was just trying to show you that single piece flow is of course the ultimate, and that is essentially coming from a car manufacturer where pretty much every product goes down an assembly line. Now, one piece flow also impacts time and system, which impacts work in process, which impacts waste identification. So personally, rather than you going out someplace and drawing a value stream map for a product, what I would advise is, you could even go and draw a simple flow diagram, also known as a spaghetti diagram, and then watch the flow of the product from raw material to finished product. How does it come in as a container, and how does it go as a container? And then watch very closely for the movement of every unit of product, watch the utilization of the employee, and watch the utilization of the machine. Of course, as regards the machine and the employee, what you care about is the bottleneck in the system. So sometimes that might take you some effort to recognize where is the bottleneck in the system. But if you look at the violations of flow, you will automatically find what is causing delivery delays, and you will automatically find sources of waste, which of course, contribute to cost. And you will also see things like safety and ergonomics violations, which you can then take action on. So focus on flow and look at single piece flow as the foundation for understanding how an existing manufacturing or service system could be improved. Thank you.